Why even customize your own agent? Surely the build and plan agent that comes with every normal AI tooling is more than enough, right? Well, not quite. In this video, we're actually going to explain why you actually should build your own custom agents and why it's actually worth the effort compared to just using the default ones. So most AI coding tools give you two agents out of the box, generally a build and a plan agent. And they're really good for simple tasks. They work fine. But here's the thing. They're a bit generic. You kind of have to, add a bit of context, get them to a state that they actually work for you. And sometimes this means you repeating yourself quite often just to get to the same results. So you really start re-explaining yourself, and it feels a bit tedious. So this is actually where custom agents come in. So when you actually build your own custom agent, you're actually determining how it actually operates. What does that actually mean? So think about it. You can decide the sequence of events or tasks that it performs. You define how it interacts with you, and you also control its behavior from start to finish. So let me show you what I mean quickly, just so we can get up to speed. All right, on screen, I've got just a blank repo. And in this example, I'm going to just use OpenCode. So I'm just going to go .opencode for this one to show you what I mean. So to start off with, I actually just want to talk about what a general agent is. So if we just run OpenCode from the get-go, we can see here we've got build, and if I press tab, it will go to plan, and now we're in plan. And these are the two defaults. If I go tab again, you'll see that it just goes between plan and build. All right, we're actually going to build our own custom agent, and we can try define different ways that it should interact. But one thing I do want to state just from the get-go is I just want to say respond with hi, so we can have a test case of the context used. So if you look over here, we'll see the context. And at the moment, this is just for plan. It's 10,382. Build will be about 200 tokens, more than that, just because of the system prompt. But that's our baseline test. All right, so now we're just going to build our own custom agent here. So in OpenCode, we're going to just go new folder. We just call it agent. And for this one, I think we're just going to make our own little my agent. And we're going to just customize the way it responds. All right. We're going to just take those tools. We're going to keep it quite simple for now. And we're going to define our model. All right. So the most important things just for this is you just want to make sure it's primary. And you can give it a description of whatever you want. Whatever the agent name is here is what it will be picked up in OpenCode. And we are telling it, hey, always say hello world. You can only say hello world, nothing else. Never say anything or solve any problems or do any tasks. All right. This one's just to show we can influence the behavior of our agent. So if we switch, we got on our agent here, and I can type, I really need help issue, and it should only respond back with hello world. All right. So we kind of cap this agent. So let's make this a bit more useful. Maybe let's make it always all right, just to customize the behavior a little bit, we can do it like this. Always plan, the user's requests, ask for permission to proceed, build the solution, and we just say digging in when you're building a solution, and then test the solution to make it work. All right, pretty simple stuff, and we can just exit this because we want to get the new one out. And if we go back to my agent now and we say, I want to say build an auth system for whatever reason, you'll see it should start doing a few planning. So it'll ask, some questions, things like that from the get-go. And it's also just trying to see if there's anything in the repo. Yeah, so it's finding nothing. So proposing a stack, and then it will ask for permission, should we proceed? So we can see it's actually planning all of this out according to the instructions. Great. And we could say proceed, and we know it will follow these instructions. One thing you'll note is it did all of that, and it's on 11,588 tokens. That's because it output all of this. But that's quite great. We know it did quite a bit, though. So this is a bit more useful than our build agent. We could say we wanted to build all of this, but it might not refer all of that. But let's actually try that. So let's actually just go new here. And let's actually go to build. And let's see how build does this. All right, so we can see build is also kind of giving us some things. Would you like to proceed with this plan? So quite similar, GBase, and it used 13,000. And our one here was 11,000, so a little bit more efficient. And this one gave us a bit more file structure, all the rest of it, because it kind of made the plan based around it. So it really tried to understand everything. Rebuild kind of just said Express.js. What did this one say? Node.js plus Express, very similar. SQLite, so this one's Postgres. So slightly different from each other, but quite similar. Not too much to read into. But what we can see is we can see a predictable behavior change a little bit. We can see this actually has a better plan. Let's proceed and asking me to proceed with this plan. Build is also saying the same or asking for a different one. This one's just saying, hey, let me know, and we'll get started. So build's still trying to figure out everything. Plan is just like, this is the plan, do you want it, yes or no? So we changed the behavior slightly. All right, great. So we can actually change this a little bit. Yeah, we can also say, I only want to work with Python code, for example. And if we just exit this and we actually do the same thing, we go back to my agent here, and we just say, we can know it's going to do the plan again, but it's only going to do it for Python now. So let's see how it runs through this. So we can see it's doing the whole plan again, very repeatable behavior. And we can see it is consistent. And its tokens are 9,500 now, a lot less than the build. So hopefully you can see custom agents give you a bit more control on how it behaves, and it makes a bit more of a repeatable process. Okay. All right, so this is the next part I care a lot about, and I really want to go in a bit more detail here. What's actually happening under the hood? Remember, we look here, this is 9,500, and this is 13,200. And if I just open a new terminal here, open a new terminal and I just run OpenCode, and I just go to build and I say hi, we'll see this will be 10,000. And this is higher, 1,000 tokens higher than just our prompt agent here. And that's because we can define the prompt a bit more. And let me go into detail what's actually happening a bit under the hood. All right. So on my screen, you'll see I have a context window. We have a system, prompt, tools, user messages, and everything. So what's happening when we use build? So in this case, say we're using the build agent. Okay. Build agent has its own prompt, has its own system prompt. Okay. So in the system prompt, I'm just going to make this blue for whatever reason. All right. So the build agent has its own system prompt. And when it loads the system prompt, and it loads whatever tools that is needed. And then it loads the user message. And we know that this, with just a simple hi statement, we know that this is at about 10,000 tokens, okay? With an AI response, this is just like the simple one, depending on how long it can get up to this. I think we said about 13,000 on our last one. All right, so we can see we're already quite a few tokens in just from very few messages. And this is where it gets really important. We kind of want to keep our, all right, this is where it gets really important. So we want to make sure we kind of keep our context under 100,000 tokens in total. Why is this the case? Well, we know from previous studies and other AI papers, as soon as you get to about 50% of your context window, or around that 70K to 100K context window, performance drops to around 50%. 50%. Let me just state how important that is. That means it's literally half as bad when it's at 100K tokens. So you can't really rely on it. So if you're expecting great results, it's kind of like, think about when you're at the end of your day on Friday. Not really going to give the best performance. All right. So we want to make sure whatever we're doing is staying under this 100K token limit because we really care about the performance. I'm stating 100K here because this is an easy figure to remember. And this only works for one of the premium models like ChatGPT, Claude, things like that. Want to keep under 100K. This is like my rule. And this is where context engineering comes in. This is probably what you guys have been hearing quite a bit. Context engineering is trying to figure out how do we reduce all the context coming in here to keep under that 100K. All right, so this is where custom agents builds on top of this. So we can have two types of agents. We can have primary agents and we can have sub agents. Okay, so we can have two different agents. And what's nice about these is each agent has its own context window, okay? So each has its own context window. And why is this important? Well, we just stated up here, we want to make sure we stay under this 100K context limit. But let me talk about a scenario. So we're going to only be using the build agent. And we know the build agent only has the system prompt. I'm just going to copy all of these. So we know that the build agent has its own system prompt. I'm just going to system prompt and the tools all in one. But say we send a message. Let's say build and fix X. All right. And say we've got a code base already. So this is going to be our code base. It's going to be nice and red on code base. All right. What's going to happen is this is going to, let's just make this brown. It's going to do a grep. So tool call and find info. Right. So what's going to happen is this build agent's actually going to use a tool called grep, and it's going to try search through our code base here. All right. And it's going to look at all these little files in our code base and try read each of it. What actually happens when it's doing that? When it's reading all this context, what's happening? Guess what? It's actually filling up our context window again. And this will just be like the search information. Okay, it might be reading files. It doesn't really need to fix that problem. It might be reading your whole entire, system prompt. It might be reading your entire code file just to find where the problem is, because maybe your code base is not very well laid out or well structured, so it really does need to jump through a lot of files to understand what's actually happening in your code base before it proposes the changes. So we start ballooning our context window like quickly. And again, remember, we're trying to keep under that. We're trying to keep under that 100K limit here. So the more we search, the quicker we get to the 100K, and our performance drops to about 50%. Remember, we're trying to keep our context as low as possible. 100K doesn't mean just keep going into 100K, but it is a nice threshold so we understand when performance really starts to degrade. So if we keep searching and trying to gather all the right files, which we don't know what they are yet, we know our performance is going to degrade. So say after all the searching, so let's just make this a bit bigger, and let's drop the line here to about here. So that's 100K. So say after all of this, we're at about, let's say we're about 70K here, which means we've got about 30 to work with before we drop to that 50%. Remember, we're probably at about 70% performance, give or take. Okay, and here we'll be at 50. All right. So that means within the 70% to 50% performance, we're actually building our code with this capability. We're not building it with the 80 to 100% performance that we see on benchmarks. So we know up here. So we know up here we had the 80% to 100% performance in terms of code quality, but we're actually generating code at the 70% performance here to 50%. And let me ask you, what do you think the probability of getting great code in the 70% to 80%, in the 70% to 50% performance range. Do you think it's the best code you're going to get? Or do you think you're going to have a lot of debugging to do? And worse yet, maybe you go over the 100K like token limit, which I bet most of you actually do. If so, you're probably debugging constantly. All right, so this is actually where sub-agents come in. We can actually use sub-agents to perform similar tasks that don't need the full context of everything, but can perform an action for us and then return a result to let our main agent proceed. So we can actually let our sub-agent search the files and only return the files back to this main agent of what's actually necessary. So the sub-agent can say, look at Z files. And it can give the exact links and line numbers that it needs to look at. Now our main agent doesn't need to search the whole code base because the sub-agent is filling its context window with the searching and then only returning back the relevant results according to what's needed for the search. Now, we're not really at 70%, we're probably closer to that 80% performance that we actually care about. Now we can start generating code. And this is where custom agents become super popular. All right. And I haven't even touched on context files here yet. So we hear about context engineering all the time. And basically what we're talking about is how we determining how the AI agent is performing a lot of different types of tasks. I've only just shown one section that's just searching through the code base. They could be coding standards, they could be how you interact with your database, it could be how you deal with certain business logic, all of that. That's a lot of context, and you don't want to put all of that in your system prompt. And this is where your context comes in. So the old way would be you just make a giant system prompt. So you just make a huge system prompt here. So you'll just have a system prompt. All right, so the old way, you'd literally just have a system prompt. And you would just fill that context right here with all the information, standards, you name it. Yeah. But there's a better way. We already know there's a way to search for files and then put them in. And this is where lazy loading comes in. So instead of referring to the file itself, you tell it where the file is so it can pull in when it's needed. All right, so let's just jump back to the code. How does this work? So say we've got, let's just make a new file here. I'm just going to call this standards, and I'm just going to call it .md. All right, and doesn't really matter. All right, so I can say use the following standards. And I can, if I go at standards like this for OpenCode, this at symbol actually tells OpenCode that it needs to pull in the standards.md straight away. So this will actually fill up the context window from the get-go. All right, but we're going to do some lazy context loading, okay? All right, so to do lazy context, you'll see we can just specify, hey, when standards are needed, please just load this context. And this is a way we can tell our agents to actually go and load our files. This is super important. So just jumping back to our thing here is now when we need it, we get the system prompt could load, could start, and a request comes in. So let's just actually just quickly do this. So let's just say a normal request comes in. So we have our system prompt. Say the user says they want to work on, let's just say, or system as our example. And say we've got a particular, so let's just make this red so we know it's the user. All right, so the user says, okay, we want to work on an OR system. So the AI agent's like, okay, we know that's an OR system that has to interact with the database. So it's okay. All right, so then the system probably says, okay, we need a database. and standards. All right. But if we know in the system prompt, it says, hey, go grab from our standards MD, when it needs this, it will pull this straight away. So what's nice is it'll pull that into our context. And then it will then determine what it needs to build. Then it can probably build the OR system using the standards. So in a way, we allowing the AI agent to have a lot more flexibility on what it can do. We don't really have to always guide it. And this is where context engineering gets very bit more interesting, is how do we reduce our context so we don't ever hit our threshold, so we get the maximum amount of performance out of our agents. And this is where building custom agents really shine. Anyway, I've scratched the surface. I don't want to go too much into detail here. I think I've kind of covered enough. Hopefully this gives you a clear guideline on what's actually trying to happen under the hood. All right, so just to sum everything up. Yes, default build and plan agents are fine to get some simple tasks done, but you seem to always repeat yourself to get to the same standard each time. But if you want agents that truly understand your workflow, maintain consistency, and you don't require constant hand-holding, building your own custom agents is the way to go. So you get to define how they operate, and you control what they can, what context they can receive, which allows your productivity to skyrocket because you're not taking care of it the whole time. Anyway, if you found this video useful and you really are thinking about building your own custom agents, I highly recommend you check out my open source repo called OpenAgents. It's still early days, but the goal is to create different agents for different activities, from content creation, code reviews, testing, you name it. And it will allow us to produce custom and repeatable results. We are going to validate each of the results from the agents with evals to make sure they actually work the way we do. Just because you make a good system prompt and you refer the right context files doesn't actually mean it gets pulled in at the right time. So having those evals in place is very important. Anyway, check the repo in the description below. And if you do have any good agents or want to contribute your own, please just, hit an issue up and let's discuss, and maybe we can pull it in and other people can enjoy your agent. I hope you found this video helpful. And if so, I'll see you in the next video. Thank you for watching. Cheers.